Hello, everyone. My name is Manvith,
And I'm Sanjit.
and welcome to the Learnable Organization channel. Um,
Today we're going to be talking about solar system formation in Unit 3, the solar system, in our course Astronomy 101.
this will be our first video in Unit 3, and so please make sure to stick around till the end. And we're going to talk a lot about the solar system, and so it's going to be really fun. So let's get started. So, first, let's give you a small overview of the solar system, what it really is. The solar system is where we live, of course. It is the area where 8 planets, maybe 9, if you know what I mean. We'll talk about that later in the video. Rotate around one sun. In the center of the system, there are many. In the center of the system, there are many solar systems everywhere in the universe, but ours is special because it's the only one that holds life. At least that's what we know for right now. This is because our planet, the Earth, holds its orbit in the habitable zone, or the Goldilocks zone, which is an area of the planet, which is an area where the planet doesn't burn up due to too much energy from the sun, but also due to the lack of energy from the sun doesn't freeze up. Now let's talk about how the solar system formed. The solar system formed when the planetary nebula, like the Orion Nebula, became unstable and collapsed because of the many supernovas from the huge stars that burned their fuel too quickly. This caused the dust and gas to collapse into itself, and with all the gravity and angular momentum, it turned into a disk called a protoplanetary disk. At the center where the dust and gas was super dense, it formed a protostar, and when the core finally became hot and dense enough, it ignited fusion, and in the inner part of the disk, the dust particles, which are the size of the grain of rice, were flash heated into chondrules. The source of this heat still remains a mystery. Those chondrules clumped together and formed planetesimals and asteroids. The planetesimals kept gathering material and other asteroids until it finally cleared its path. The planet was now so big that under its own influence of gravity, it formed a sphere. This is how the inner planets formed. In the outer part of the protoplanetary disk, the planetesimals gathered gas around themselves, forming the gas giants we see in other planets. All the heavy elements and water we see in our own solar system and on the planet was the result of fusion from population 2 and 3 stars. The sun is the central star of the solar system, comprising 99.86% of its total mass. Now, Sanya will be talking about the inner planets.
The inner planets of our solar system are the four planets that are closest to the sun. They are also known as terrestrial planets due to their rocky composition, like Earth. The inner planets, first we're going to talk about it in order, which is in proximity to the sun: Mercury, Venus, Earth, and Mars. Between the inner planets and the outer planets is the asteroid belt. The inner planets are approximately 1.524 AU long, which means that 1 AU is the distance from the sun to the Earth. So the yeah. Next up, we're going to be talking about the asteroid belt. The asteroid belt is an area between the inner and outer planets.
Let's talk about how inner planets formed. And so the inner planets formed because as we were talking about earlier, the chondrules were flat the uh grains of dust basically were flash heated into chondrules, and they clumped up together, formed planetesimals, and those planetesimals kept getting bigger and bigger until they formed inner planets. And now let's talk about the asteroid belt.
Yeah. Okay. The asteroid belt, like I said, is an area between the inner and outer planets where the most rogue asteroids, meteorites, and other things stay in orbit around the sun. It is thought that this belt formed because of Jupiter's and outer planets' immense gravitational force, pulling everything that are not planets towards it. Some asteroids are lucky enough not be part of this ring and are elsewhere in the solar system. But most of these non-planet objects orbiting inside the SS are inside the asteroid belt. The asteroid belt is approximately 1 AU long, which is approximately the distance from the Earth to the Sun. Um, Next up, Manoj will talk about the outer planets.
So after the asteroid belt are the outer planets. The outer planets in our solar system are the 4 planets that are the furthest away from the sun. They're also known as gas giants because they are primarily composed of hydrogen and helium, and they also have thick atmospheres with no solid surfaces like the inner planets, except the core, of course. The outer planets in order of the distance from the sun are Jupiter, Saturn, Uranus, and Neptune. The outer planets region is 27.476 AU long. Now let's talk about how the outer planets form. In the outer part of the protoplanetary disk, the planetesimals gather themselves all the gas and dust that was there. And since this was further away, there's just gas and dust there compared to more like solid materials in the inner planets because there's more dense material there compared to the outer planets. And so all those stuff like all the gas and dust clumped on the cores of the outer planet, and so that's what caused outer planets. And so now let's talk about the Kuiper Belt. The Kuiper Belt is a vast region of space in our solar system that lies beyond the orbit of Neptune. It is named after the Dutch American astronomer Gerard Kuiper, who first proposed its existence in the 1950s. The Kuiper Belt is a disc-shaped region and is believed to be the home of many ice bodies, including dwarf planets and comets and other small celestial objects. It is 30 to 55 AU long. Some of the key features of the Kuiper Belt are this. So let's talk about its location. The Kuiper Belt is located beyond the orbit of Neptune, extending about 30 astronomical units to 50 AU from the sun. 1 AU is the average distance between the Earth and Sun, which is about 93 million miles or 150 million kilometers, sorry. The composition of the Kuiper Belt is mainly composed of small icy bodies similar to the composition of comets. These objects are made of a mixture of water, methane, ammonia, and other ices, along with dust and rocky material. Now let's talk about the formation of the Kuiper Belt. The Kuiper Belt formed from leftover materials from the early solar system's formation, with the gravitational interactions with giant planets like Jupiter and Neptune, scattering icy planetesimals in the outer regions. Over billions of years, and gravitational interactions, this is what shaped the Kuiper Belt into its current structure. Now let's talk about dwarf planets. Several dwarf planets have been discovered in the Kuiper Belt. The most famous among them is Pluto, which has a lot of controversy. This was first considered the ninth planet for solar system until it was reclassified as a dwarf planet by the International Astronomical Union in 2006. There are also many comets in the Kuiper Belt. The Kuiper Belt is a significant reservoir of comets. Short Myriad comets, which have short orbits, take them around the sun in less than 200 years, are thought to originate in this area. When these comets get close to the sun, they develop in tails and their ice vaporizes. We'll be talking more about comets later in the video. Exploration of the Kuiper Belt is mainly by the New Horizons spacecraft launched by NASA in 2006. It conducted a flyby of Pluto and its moons in 2015 and provided the first close-up images and scientific data of this distant region. New Horizons has continued its journey into the Kuiper Belt and encountered a smaller object named Arakat, previously known as Utomo Thule, in 2019. Now let's talk about the heliosphere. This is the key features of the Kuiper Belt. So the heliosphere. This is the region that surrounds the solar system and is made of the sun's magnetic field, free protons and electrons. This contains the termination shock, while the boson is outside of this region. We'll be talking more about these terms later in the video. The heliosphere is made from charged particles that are constantly given out by the sun. It is important as it protects the SS from particles outside and from the radiation from these outside particles, of course. It is continuously inflated by the plasma originating from the sun, known as the solar wind. The heliosphere is very important because it is what protects us from interstellar radiation. Without the sun's heliosphere, all the solar system would be irradiated and life wouldn't have even formed on Earth. So Sanjay will be talking about the termination shock next.
The termination shock is the point outside of the SS where the particles from the sun protecting the SS slow down to under the speed of sound. This is because of matter being expelled from the sun, slowing down and losing energy, which causes it to react more with the interstellar medium, which is basically just free hydrogen and gas clouds in space. This reaction to the ISM causes the matter from the sun to slow down even more, creating a kind of bubble where the matter from the sun slows down significantly. Next, Manu's going to talk about the heliosphere.
Actually, Sonia will be talking about this.
Okay. The heliosphere is the outer region of the heliosphere, just beyond the termination shock. The point where the solar wind slows down abruptly, becoming denser and hotter. The solar wind piles up as it presses outward against the approaching wind in the interstellar space. It is a broad transitional region between the termination shock and the heliosphere's outermost edge, the heliopause. The heliopause is a boundary in space that marks the outer edge of the heliosphere, the vast region of space influenced by the sun's solar wind. The solar wind is a continuous stream of charged particles, mostly electrons and protons, emitted by the sun and they expanding into space at high speeds. The heliopause is a boundary between the solar wind and interstellar wind, where they're in equilibrium. Next, Manat will be talking about the bow shock.
So this is an area that causes interstellar wind, free particles around everywhere, to stop in its tracks before it gets to the solar system. This protects the heliosphere and everything inside from the radiation in the form of interstellar wind. The bow shock is made of the fast-moving solar system to offset the material in the cosmos out of its way in the form of a bow. As it heats up, the matter is pushed aside and dispels energy in the form of light, making a bow in front of stars or indoor DSS. So this is a bow shock. It's like kind of like a bow, like an arch. So yeah. Now let's talk about the next region of the solar system, the scattered disk. The scattered disk is the region of the outer solar system that is populated by a group of icy objects, primarily minor planets and dwarf planets. It lies beyond the Kuiper belt that extends further from the sun, ranging from about 30 astronomical units to more than 100 AU. So, scattered disk objects are believed to have been influenced by gravitational interactions of the giant planets, primarily Neptune, during the early history of the solar system. These interactions caused some of the objects from the Kuiper belt to be scattered into more eccentric and inclined orbits, giving rise to the scattered disk. The scattered disk objects have a wide range of orbits, and some of them can even approach the inner solar system and they may even develop a coma or a tail, resembling comets. As such, some scattered disk objects are classified into scattered disk comets. One of the most famous scattered disk objects is Eris, a dwarf planet located about 96 AU from the sun. Eris was one of the objects that led to the reclassification of Pluto as a dwarf planet, as it is larger and more massive than Pluto. Now, Sanjay will be talking about the Oort clouds formation.
The Oort cloud formed at the early stages of the solar system. It's made up of long period comets. The reason why the Oort cloud was formed is because Jupiter and the gas planets flung the comets into deep space, which caused the Oort cloud. The Oort cloud contributed to a lot of the long period comets which we've observed, where they have very irregular, long, and parabolic orbits. These comets can be very dangerous as they can cause an extinction level event, like the dinosaurs. What happened to the dinosaurs? We haven't discovered any Oort cloud objects yet, but two objects we might think that might be Oort cloud objects are Sedina and BP113. Sedina's orbit is 140 billion kilometers from the sun, while VP's orbit is just 70 billion kilometers from the sun. The Oort cloud's inner edge starts from 300 billion kilometers from the sun, while the outer edge might be 10 trillion kilometers from the sun, or almost a light year. Next up, we're going to be talking about the Hill sphere.
So, the Hill sphere is of the sun is 1 light year, which means that everything inside the sphere is attracted to the sun, but anything outside is attracted to other stars or objects. So now let's talk about Planet 9. This is a hypothetical planet, which I was referring to in the start of the video, and that orbits far away from the other planets, and is thought to be the source of clusters of orbits of various objects far away from the Neptune orbit, called extreme trans-Neptunian objects, or NTNOs. This hypothetical planet is thought to be 5 to 10 times heavier than Earth, and around 400 to 800 times further away from the sun compared to the Earth. It is also suggested that this is the core of the planet. This is the core of the planet forming that was pushed away by Jupiter near the start of the solar system. There are other ideas that the planet was a rogue planet captured from another solar system, or was formed closer and pulled further away by another planet. But this planet is not the same as Planet X, which you may have heard of, as this is a disproved hypothetical planet that would have changed the orbits of Uranus and Neptune if it existed. Now, Sanjay will be talking about comets and their formation.
So comets are classified based on the duration of their orbits around the sun. Comets are basically leftovers from the dawn of our solar system around 4.6 billion years ago and consist mostly of ice coated with dark organic material. They've been referred to as dirty snowballs, and they might yield important clues about the formation of our solar system. First, short period comets. Short period comets need roughly 200 years or less to complete one orbit, while long period comets take more than 200 years. Short period comets are generally divided up into Jupiter family comets and Halley type comets. Jupiter family comets are short period comets that complete an orbit of the sun in less than 20 years, while Halley type comets are comets with a period between 20 and 200 years, named after the first identified member, Halley's Comet. These comets orbit between the orbit of Jupiter and Pluto and are thought to be long period comets that slowly migrate inwards, or Jupiter family comets that had been slingshotted outwards by Jupiter's gravity.
So now let's talk about long period comets. Long period comets take more than 200 years to complete one orbit around the sun. They are less predictable than short period comets, and many of them arrive from a region called the Oort cloud, about 100,000 astronomical units. That is 100 times the distance between the Earth and the sun, from the sun. These Oort cloud comets can take as long as 30 million years to complete one single trip around the sun. Now let's talk about how comet tails are formed. Comets develop tails as they are approach the perihelion, the place in their orbits when they are closest to the sun. The sun's heat vaporizes some of the comet's material, releasing dust particles that were trapped in the ice. The ion tail is formed because the neutral gas initially present in the cometary coma is ionized by the solar radiation, giving birth to ions. These ions are susceptible to magnetic solar flares and are therefore swept out of the coma into the long characteristic ion tail. Now let's talk about asteroids. An asteroid is a small rocky object that orbits the sun and is larger than a meteorite. There are three broad composition classes of asteroid, and they are C, S, and M types. The C-type chondrite asteroids are the most common. They probably consist of clay and silicate rocks, and they appear dark in appearance. They are among the most ancient objects in the solar system. The S-type or stony asteroids are made up of silicate materials and nickel and /iron. The N-type asteroids are metallic, and they're made up of nickel and iron. Now let's talk about meteors. A meteorite is a small piece of an asteroid or comet that enters the Earth's atmosphere and burns up, causing a streak of light to form in the sky. A meteorite is a meteoroid that has hit the Earth's surface. Meteoroids are distinguished as objects significantly smaller than asteroids, ranging in size from grains up to objects a meter wide. Objects smaller than meteorites are classified into micrometeoroids or space dust. Thank you guys for watching our first video of the unit 3. We hope you guys learned a lot today, and next video will be about the planets in our solar system in depth. So thank you for listening, and please subscribe to our channel. It'll really help us out.